Let's use a Venn diagram to help us understand probabilities involving AND. The examples that I'm going to do are going to be for the roll of a single six-sided die. So let's just draw the tree for that real quick. There are 6 outcomes. And we're going to let event A be rolling an even number. 3 successes for that. So our probability is 3 over 6. And event B can be rolling an odd number. We see that there are also 3 successes for that. But now we want to put the outcomes in the sample space into their correct areas in the Venn diagram. So where should 2, 4, and 6 go? Well, they're even, but they're not odd. So they need to go in the A bubble, but they can't be in the B bubble. What about the odd numbers, 1, 3, and 5? Well, similarly, they have to go in the B bubble, but they cannot be part of the A bubble. And that's the correct Venn diagram for this situation. We can use the Venn diagram to calculate our probabilities. Like say I just wanted the probability of A. All I would do is look for the outcomes that are in the A bubble. They would be successes. Count them up and put that as your numerator. And then see that there are 6 total outcomes. And there we go. I found the probability from the Venn diagram. So that means that we can also find the probability of A and B from the Venn diagram. But we're looking now for successes of both A and B. So we want to look in this middle region here. But do we have any elements in that region? For this situation, we don't. So our numerator will be 0. And this is a graphical way of showing that the probability of A and B is 0. It can't happen. Let's look at an example where there actually may be some overlap. A will be defined as rolling a number that is greater than 2. And B can be rolling a number less than 4. Now on the side here, I'm just going to list the different possibilities, and let's see if we have any overlap. Let's see, we got 1 through 6. I'll circle numbers which are greater than 2. 3, 4, 5, and 6. Over here, I'll circle numbers that are less than 4. 1, 2, and 3. Is there any overlap? There certainly is. 3 is an outcome that is shared by both events. So that means that 3 needs to go in the A and B space. Other numbers that are greater than 2, though, besides 3, would be 4, 5, and 6, but they go in the A only region. And numbers which are less than 4 would be not just 3, but also 1 and 2, and they go in the B only region. Now, can we use the Venn diagram to find the probability of A? Yes. What we want to do is we want to look for any outcomes which are inside the A bubble. And it's not just 3, there's 4 of them. So we have a 4 and 6 probability of rolling a number greater than 2. Can we find the probability of B from the Venn diagram? Yes. Now we'll want any outcomes that fall inside the B bubble. And there are 3 of them. So it's a 3 in 6 probability. All right, lastly, let's find the probability of A and B. Our successes this time will be anybody who's in this middle region. And there is one. So our numerator will be a 1. Our denominator will be a 6. And our probability of A and B is 1 in 6. All right. That brings us to the definition of mutually exclusive events. Events A and B will be mutually exclusive if it's impossible for both events to occur simultaneously. When that happens, we find that the probability of A and B is 0, meaning they can't both happen simultaneously. Now, which events above represent mutually exclusive events? So one of these situations is mutually exclusive, and the other is not. And the top one is the one that is mutually exclusive. You can't roll an even and an odd on a single roll of a die. That means this situation down here below is actually called not mutually exclusive. All it means is that it is possible to have an outcome be part of both event A and B.